Hello and welcome to an introduction to Ricardo WAVE. My name is Adriaan and today I'm going to show you how to get familiar with the Ricardo WAVE environment and how to build your first one-cylinder model. So on your screen you can see the finished one-cylinder engine model that I will show you how to do throughout this video. But before we get started, first let us familiarize ourselves with the setup and the environment of this canvas. Now what you see in front of you is the model canvas, and this includes all the components of your engine model. In order to move it around, you can press your middle mouse button and you can move the model inside the model canvas. And if you want to zoom in and out, you just use your mouse scroll button. On the top left, we have the Wave Elements library, and you can see there is a bunch of different Wave components, from flow elements, which is your ambient elements, your cylinder, ducts, injectors, throttles, and then you get mechanical elements such as your turbo shaft. You get control elements such as your sensors, actuators, and then also signal processing blocks such as your filter and function blocks. There are also numerous other components which you can have a scroll through and see what they do. If you want to use one of these components, simply click on it and drag it onto the model canvas and it will appear. Then at the bottom left, we have the model elements tree or the session tree. And this is basically just a tree showing you all the components of the model, and you can select them by either clicking on them on the model elements tree. For instance, I can select cylinder 1 in the elements tree, or I can also select it directly by clicking on it on the model canvas. Then here at the bottom is the selected objects help file. If you are unsure of what inputs the selected object needs or outputs that it can generate, you can always have a read through at the help file and it will tell you everything you need to know. We also have a little output tab here at the bottom that when you select it, it will show the output or any messages that come up when you run the model. Then lastly, here at the right, we have the object properties. And this is where you go and input all the characteristics of that object. And for this cylinder block, you can see there's the bore, the crank stroke, clearance height, and all the other properties that you may want to enter when you create this block. Lastly, you also need to be aware of the model properties or the general model properties option here in the elements tree. If you click on that, it will just show in the right all the general properties, such as the type of fuel you are using. In this case, it's idling, as well as what compressibility functions you want to use. There's also at the top a comments tab where you can go and input any comments you want, especially if you are changing your model and want to keep track of the changes you made. Now that you're familiar with the setup of the program, it's now time to build our one-cylinder engine model. So if we look at the finished product again, the model consists of an ambient block for the inlet and an ambient block for the outlet. We also have two ducts, one representing our manifold and our ports to the inlet, and one port for the exhaust and manifold for the exhaust as well. We also then have a cylinder block as well as an engine block together with our inlet and exhaust valves, and then finally an injector which represents our direct injection fuel delivery. So let's go and recreate this model. As I mentioned before, if you want to add blocks to the model canvas, just drag and drop them from the Wave Elements library. In this case, I'm going to grab hold of my ambient element and I'm just going to drag and drop it. Next, let's add the remaining elements from the Wave library. It's always nice to make your model neat from the start, so we are going to select all these elements and we are going to align them horizontally. And to do that, we go here at the top and you will see there's a little rotation button and then there's two arrows. If we click on that, here you can see is the align option and we want to align middle. Similarly for the injector, cylinder block and engine block, we want to align them vertically. You can also select individual parts by just holding in the shift key. So if we select them all and we go and align them vertically. Once we are happy with our layout of our engine model, we can start connecting the blocks with each other. So we can go and connect our ambient, hold the key in, you will see a little line appears, and we connect it with the inlet of our duct. And then similarly from the outlet of the duct, we connect to the inlet of the second duct. And now if we go and we connect the outlet of our port duct to the engine cylinder, a valve will automatically be created. And there is the valve that's been created. We also need to do this for the exhaust ports. An exhaust valve will also be created when we connect the cylinder with the exhaust duct. And lastly, our cylinder needs to be connected with our engine block. Because the valves have been created, they are not aligned vertically, so we can repeat the exercise of aligning all our blocks. We can also just rotate these valves. Again, you will see rotation is at 15.3. Just set that to 0 and it will align. It will rotate the element correctly. Before we start editing the block's properties, we need to go and rename each block into a more descriptive name. To do that, we select the object, and then at the right top, you will see the name label appears with its name. So we just need to change that, and we can change it to ambient in. Let's do the same for the other objects. Now we are ready to go and change each object's properties. You will notice that if we select on the ambient object, the properties at the right, and we look at its initial conditions, the fluid state and fluid composition, and by looking at it we can just press on the little pencil button, we will see that by default the pressure is set to 1 bar and 300 Kelvin. This is true for the inlet and the outlet ambient objects, and we are going to leave it as is because that is our atmospheric properties. For this one cylinder engine, we are going to use the following geometry. See if you can go and change the object's geometry as per the picture. If not, keep on watching. Now we are going to start off with the cylinder's geometry, inputting the bore, stroke, connection rod and compression ratio. Now in order to access the object's properties, we need to select it. We can do that either by clicking on the object on the canvas or on the model tree on the left bottom. Once we've clicked on it, the properties will appear on the right, and we can go and edit the properties as required. You'll notice as soon as you make a change to the default values that was in the text boxes, the input values will be bold, which is a good indication to show you that it has been changed. Next, let's do the inlet manifold. The inlet port is next. Let's do the exhaust port. The last duct is our exhaust manifold. And those are all the values necessary for our engine geometry, which is our duct diameters and lengths, and our cylinder bore, stroke, connection rod length and compression ratio. Next, we need to set the initial conditions for our intake and exhaust geometry. That's usually our initial pressure and temperature. Now for this example, our initial pressure and temperatures for our ducts will be the same as that of the ambient object. So a quick way to go and apply these initial conditions to the other objects is to go to our model tree, and we will see there at fluid states there's a default fluid state, and if you click on it at the right top it will show us the pressure of 1 bar and temperature of 300 Kelvin. We right click on it and we say copy. Once we've copied it, we can paste it twice in the same fluid states, and you will see it appears as fluid state 1 and fluid state 2, and then we can rename it as intake initial and exhaust initial. Now to apply the initial conditions to all the elements for our inlet, we can select all 3 elements, and in the right you will see the edit form for multiple selections will appear, and it's divided into sections for each element type. So you can see here at the top is our ambient element, and if you go down, there is our duct element, and we are interested in our duct element. Right at the bottom, we have the fluid state, and you will see it is automatically selected as default fluid state, and we can now go and select for the intake. We take our intake initial. We can do the same for the exhaust geometry, so we select our ducts and we select the fluid state as exhaust initial. Now all the inlet geometry and the exhaust geometry is linked to one initial state. So if you want to change that initial state in the future, we only need to change it at one place, and all the geometry's initial states will update accordingly. Now before we continue any further, make sure that you save the model. The next step is to create the submodels for our cylinder. Now with the cylinder selected, we can go to the tab at the top, which indicates submodels. We can click on submodels, and then a bunch of options appear that we can use. Now the type of the model is already set at 2 zones. We will keep it that way, and you will see at combustion it is currently empty. So by clicking the little green plus button, we create a combustion submodel, and we need to select the SI WAVE combustion model. We're going to leave the heat transfer to its default convective heat transfer model for the moment. Now let's select the engine block. The engine shape is in line, as we're only dealing with one cylinder, and then the mixture type is currently set to none or motoring. We want to change that to homogeneous, which is our spark ignition engines. You will also see here at operating condition, there's a default engine speed value of 2500 RPM. We are going to replace that with a variable called speed. If we press enter, you will see a little box appears telling us that there's a new undefined parameter. We just need to add it to our parameters list. We can put in here a comment and just say that this is the engine speed, and we can change the value to 6000. Once that's done, we can add it. Now let's move on to the intake valve. We can select the intake valve, and the valve type at the right top should say lift. We can set the reference diameter to 35 millimeters, and we leave the geometric diameter as auto. And what this does, it sets it to 1.1 times the diameter of the attached port duct. And this is a reasonable default for poppet valves on an engine. Next, we need to add a lift profile for our valve, and to do that, again, we just press on the green plus button to add the default valve lift profile. And now if we press the little pencil button to go edit it, we can say that in general we need to specify it by using tag. The nice thing about tag is there is a lot of predefined values saved within Wave. So if you want to use a tag rather than your own values, then it'll be much quicker. And for this tag, you can see it's automatically selected to SI, which is spark ignition 1 inlet valve. You can also have a look and say show our valve lift. And then when you do that, you will see a nice little graph pops up showing us the valve lift profile. You can click on the show valve lift button again to go and minimize the screen. Next, we go and change our cycle anchor to 330 degrees, as well as our lash to 0.15 millimeters. We can return to the valve editor by just clicking the yellow back button here at the top. And then lastly, we need to make sure that our flow coefficient profile is set to typical valve flow coefficient profile. We can click on the edit button to have a look and see how it looks like. And again, we can click on the button saying show flow coefficients just to see how it looks visually. And there is our graph. We can go through the same procedure for our exhaust valve. We click on it, we change our reference diameter to 28 millimeters, and we create a lift profile, which again we are going to use a tag, and we are going to specify the exhaust valve lift for an SI, for the SI tutorial, which is SI1 exhaust. We also need to set the cycle anchor to 100 degrees and our lash at 0.2 millimeters. Lastly, we need to select our flow coefficient profile and make sure that is a typical valve flow coefficient profile, which is the same for the inlet valve. Now the only object left is our injector. Now in order for us to connect our injector with our cylinder, we need to select it and change it to a trapped fuel air ratio injector. Once that is done, we can connect it to our cylinder. We can rename it to injector 1. we can put in a fuel air ratio as 1 divided by a parameter called air fuel ratio. Again, you will see the air fuel ratio parameter is not added to our parameter list, so we need to add that, and we can set it to 14.5. Start of injection needs to happen at -100 degrees, and our mixture temperature will be set to 320 Kelvin. We also need to set the injection rate, and this can be done by creating a new one, and then we edit it. And for this case, we are going to input the data using a table. So we go to specified by table and we say edit injection rate, and you will see here our injection rate is set up correctly. It takes 1 crank angle degree to open up fully, and then again it takes 1 crank angle degree to close completely. Can close our graph, and then lastly we also add an injection pressure profile, and we can change that from 500 bar to just 20 bar. Now we have successfully set up our 1-cylinder petrol engine as shown at the start of this video. Well done. But that is not all. Now that we've set it up, we need to start preparing for some results that we want to calculate. We can do this by requesting plotting for our in-cylinder pressure, because we are interested to see how the pressure profile looks like. Now to do that, we again select our cylinder object, and if we go again to our object properties at the right, the top tab, you will see there is an option to select outputs. If we select it, you will see nothing is shown, so we add, press the little add button, and a list of possible graphs appear. Now we are interested in the pressure one, and this is usually 201, graph number 201. You will see that is pressure, so we select it, we say okay, and our list of output graphs will be updated with our pressure graph being listed there. Now you are ready to run your model. Before we do that, let's just make sure we save. Now before we run the model, we need to make sure that our solver properties are set up correctly, and to do that we go to our session tree on the left bottom, and you will see there is a solutions folder with Wave Solver 1 which has been checked, so you can click on that, and at the right a bunch of properties appear, and we are interested in changing our simulation duration, which is currently set at 1 cycle. We want to change that to 20. The last thing we need to do is click on the running man to execute our model. Once you've clicked the running man, the window at the bottom will switch to the output tab. Some information will be shown in the window, and when the simulation is finished, you will see the word done at the end. Once your simulation is finished, we can move over to the post processor, which in this case is called WavePost, and you can see its icon is here at the top, and if you click on it, it will open up the post processor containing all the information from your simulation that's just completed. So we're going to click on that, and this image will appear. Now you can see clearly it looks different from the model that you've just created. This is just an older interface of Wave before they upgraded to the new user interface, but essentially it is still the same with your ambient in, your ambient out, your cylinder 1 and your engine block, together with your injector and your inlet and outlet ports. If we move to the right, you will see there is time plots, and underneath time plots there is pressure. Now that is the pressure graph that we specified needs to be generated when the simulation is run. And to see the results, you can simply double click on it, and this will bring up a plot or time series plot as a function of crank angle degree and pressure. And you can see nicely inlet valve closes and our pressure increases, and approximately at 7.5 degrees before top dead center ignition occurs, and we've got this rapid increase in pressure and then the fall afterwards. So that seems to have worked out nicely. You can close that. If you're interested in some of the other results generated by our simulation, you can right click on any of the components on the canvas and it will display the results. So if we go and we right click on the cylinder, we can see there is options where we can say view summary data, and this will bring up a window with a bunch of information. And you can see here trapped air fuel 14.49, we specified it needs to be 14.5, so that's fairly close. It gives you the airflow in kilograms per hour. You can get brake power in kilowatts, which is shown here as 18.5 at 6,000 RPM. Here at the top you can see engine speed is set to 6,000, and if we scroll down a lot of other information is given to us. The same can be done with the ports. If we select the inlet port, we right click it, say view summary data, you can see the pressure on the left and the right. You can see the velocity of the air, the density, the mass flow. Another way you can get all this information is to go again to the right side of our screen, and you will see there is this tab or this file sweep plots. Now if we expand that, you get a bunch of other folders: engine, cylinders, ducts, wire junctions, injectors, etc. And we can go, for instance, and look at expanding the engine folder, and then that goes into breathing, performance, pumping, fueling, friction, and emissions. Now if we go into performance, we get a bunch of different graphs. Now I did say that we had the brake power that we just saw when we right clicked on the engine block. So if we double click on this again, it will give us a graph with 1 point on it, and we can see that that is about 18.5 kilowatts, which is similar to the results shown on the summary table when you right clicked on the engine block. Now because this is a sweep plot, and this will generate a line curve if you add more cases to your simulation. We only had one case at 6,000 RPM. That's why there's only one data point on this graph. But as soon as you add more for higher or lower RPM values, you will get a nice curve of the brake power curve as a function of engine RPM. And that's it. You have successfully simulated a 1-cylinder spark ignition engine in Ricardo WAVE. Well done. What are you gonna build next? I am available on Twitter. My Twitter handle is @ASVIA90. If you've got any questions, do not hesitate to contact me through Twitter. I'm also on LinkedIn. You can send me a message on LinkedIn as well. Thank you very much for watching, and I will see you in the next video. Bye.